Hi, welcome to Essential IT and Security Skills. I'm Charles Redman, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. Certified technician. In this segment, we're going to talk about wireless networking. You'll learn and we'll discuss some of the wireless networking components, analyze and explain wireless networking standards, learn to install and configure a wireless network, and some basic troubleshooting. Today, users that want to go wireless have several options to choose from 802.11 all the way to Bluetooth. Even infrared devices can provide some limited wireless capabilities. Most telephone providers offer internet connectivity through their cell phone networks. And even most cell phone providers provide internet connectivity through their networks. Wireless capabilities are built into many of the devices that we use today, like smartphones and tablets. As a matter of fact, wireless Ethernet and Bluetooth are often integrated or can be easily added to modern devices. So wireless connectivity all starts with the access point, or the WAP. Wireless Ethernet devices connect to the internet via the wireless access point. And many of today's PCs add the option to create a Bluetooth network via a Bluetooth hub. Here you see a standard Linksys wireless access point and an external Bluetooth hub that's providing connections for peripherals like keyboards and mice. Most WAPs draw their power from a wall outlet, just like any other electronic device. However, more advanced WAPs, usually the ones that you'll see in large organizations, use a feature called PoE, or Power over Ethernet. This way they don't have to be near a standard wall outlet, they will draw their power from a network switch. All wireless devices use the same networking clients and protocols as wired networks. They use what's called CSMA-CA. The CA stands for collision avoidance. You often use the vendor-provided software to configure your wireless access point, and this allows you to customize some of the basic parameters. However, Windows does have a built-in utility as well. So there's a couple different types of wireless networks we need to discuss. First being the ad hoc network. The ad hoc network creates a peer-to-peer network with all the other wireless devices on the network. This is a convenient option for temporary networks like study groups or small business meetings. Next, which is probably what you have configured in your own home, is called infrastructure mode. This is when all the wireless devices connect to a central wireless access point. It's also called the Basic Service Set, or BSS. When using wireless capabilities with any device, security should be one of the first things on your mind. We're going to walk through 4 basic methods used to enhance wireless security. The first being sure to change the password on your wireless access point from its default settings. The next is to configure the SSID, or the name of the wireless network. Third, filtering by your MAC addresses. And fourth, using encryption. All commercial wireless access points come with a standard default password. They're easily found by just searching on the internet, so as soon as you start through the device's setup program, you should change the default password immediately. Next is the Service Set Identifier, or the SSID. This is what's used to give your network its unique name. Again, all commercial wireless access points come with the same default SSID. So, just like with your password, as soon as you start through the setup program, you should change this immediately. Another option that you have is turning off the SSID broadcast. This makes it harder for people that you don't want on the network to find your wireless network. Next is MAC filtering. By entering the MAC address of all of your known devices, any unknown devices that isn't in the MAC table will be denied access. This is a really good example of an access control list, or sometimes you'll hear it called an ACL or an ACL. However, don't confuse this type of ACL with the ACLs that you can configure with NTFS and Windows. Next will be to choose an encryption standard. Pretty much any wireless access point you buy today will come with the same set of options when it comes to encryption, starting with WAP. WAP is probably the weakest of all the encryption modes because it has significant security flaws and it's easily broken. An enhancement to WAP is called WPA, or Wi-Fi Protected Access. It is meant to be an interim security upgrade from the weaker WAP protocol. It uses what's called the Extensible Authentication Protocol, or EAP, and a security enhancement added to WPA is the addition of TKIP, or the Temporal Key Integrity Protocol. However, TKIP has some flaws of its own. The preferred option would be to select WPA2. You'll have usually two options, either being WPA2 Personal or WPA2 Enterprise. This provides a full security upgrade from WAP and WPA with significant security improvements in using the very strong AES encryption standard. To provide ease of connectivity, a lot of vendors have started providing what's known as WPS, or Wi-Fi Protected Setup. It works in one of two ways. Some devices use a push button, where first you push the button on the WPS compatible device for a short moment, usually only a second or two. And then you'll have a short amount of time to press the button on the wireless access point. From there, both devices will automatically configure themselves for a secure connection. A second option that you have with WPS is you can enter an 8-digit numeric code. This is usually printed on the device. However, because it is on the device, this presents a unique security problem. Because you need this code to enable the access, anyone that has access to the code and a WPS-enabled device will also be able to connect. The key thing to remember is, as long as you have WPS enabled, you're vulnerable to attack. The next thing to consider is your WAP placement. Where you put your access points are almost as important as how you configure them. For instance, if you're using an omnidirectional antenna, which means an antenna that broadcasts in all directions, you want to keep it near the center of your home or office. Some of the more expensive wireless access points also allow you to turn up or turn down the radio power levels. What you want to do is decrease the radio power until you can get good reception at the farthest point from the inside of your home or office, but no reception outside. The next thing to consider is the range and speed. Wireless speeds range from as low as 2 megabytes per second all the way up to 100 megabytes per second. With wireless networks, the speed that you'll realize is directly affected by its range. Your wireless access point's maximum throughput occurs about within 25 feet, even though you'll see listed a total maximum range of up to 300 feet. There are a couple of ways that you can increase your range. You can install multiple wireless access points to permit roaming between them, or you can install what's called a signal booster. Now let's talk about the wireless standards. All of them start with the base standard of 802.11. This is the wireless networking standard. However, that's about where most of the similarities end. Each of them operate on a different frequency, and those frequencies are identified as the industrial, scientific, and medical radio bands. They are 2.4 gigahertz and 5.8. The A+ examination expects you to know and understand the range of wireless standards, from 802.11a to the modern 802.11n. Here's a chart to help you out. 802.11a offers short range but very high speeds and low interference. With maximum throughput of 54 megabytes per second, it operates in the 5 gigahertz frequency. However, it's not compatible with any other wireless standards. Next came 802.11b. It is the slowest of all the wireless standards at 11 megabits per second and operates on the 2.4 gigahertz frequency. Next, we have 802.11g. It matches 802.11a speed at 54 megabits throughput, and it is also backwards compatible with 802.11b. Most wireless devices that you buy today will be using the 802.11n standard. It has maximum throughput of over 100 megabits per second, and it runs on either the 2.4 or 5 gigahertz frequency, as well as being backwards compatible to B and G. The next wireless standard that you need to understand is infrared wireless networking. This is probably one of the simplest ways to share data without any additional hardware or software. It uses what's identified as the Infrared Data Association Protocol, or you'll see it annotated as IRDA. However, to use IRDA, you must be in direct line of sight of each device. However, understand that infrared offers no security protections because it has no authentication or encryption associated with it. One of the drawbacks to IRDA is you have to be within direct line of sight, usually not more than a meter or so away. That would be about 3 feet. And it also offers no security because there's no authentication or encryption. Next, we have Bluetooth. Bluetooth was originally designed to create small wireless networks that we called PANs, or a personal area network. However, most devices only use it today to connect peripherals like keyboards, mice, and possibly a headset. It has a maximum range with Class 1 Bluetooth of up to 100 meters, Class 2 up to 10 meters, and Class 3 1 meter. Next is your cell phone. Many cellular carriers offer internet connectivity through their cellular networks. There are several different cellular standards to cover, and we're going to go over that when we look at Module 24. Next, let's talk about how you're going to install and configure your wireless network. For all intensive purposes, physically installing a wireless NIC is pretty much the same as installing a wired NIC. It just snaps into your device, and then you just install the associated drivers. Next, you'll need to use the wireless network configuration utility to configure some additional parameters. With Windows XP and later operating systems, this capability is built in. As we discussed before, you'll need to configure your SSID as well as choose the encryption standard. You'll also configure what type of network you want to set up, whether it be the ad hoc network, being sure to remember that every node must be configured with the same SSID as well as a common channel. Or infrastructure mode. This is, again, the most common mode because it's going to use one central wireless access point that all the other wireless devices will connect to. Next, you'll need to configure your wireless access point itself. All wireless access points will come with a default IP address, usually 192.168.1.1. However, check the user manual to make sure. Once your wireless access point is powered on and your device is connected to it, you should be able to enter 192.168.1.1 in your web browser. This will bring you to the administrative page where you'll be asked for the default admin password. Again, this will be in your documentation. Remember, the best placement for your wireless access point is as close as possible to the center of the area that you wish to provide wireless connectivity. If you're configuring a Bluetooth network, you're going to need two Bluetooth devices, one of them set to discoverable or listening. Next, you'll go through a step that we call pairing. This is how two Bluetooth devices learn about each other. Once the devices are paired, they will automatically configure themselves for the proper functions that each of them are possible. Let's look at some common troubleshooting steps associated with wireless networking. The first question you should ask is, who's affected? This will allow you to localize the issue to which wireless access point might be causing a problem. The next question you should ask is, what's the nature of your network problem? This is going to help you zero in on a particular service or application that your users are finding problematic. And then ask, when did the problem start? Was it because of one single action, or were there some outside influences that possibly caused the problem? Once you ask these basic questions, then you'll be able to identify some proper troubleshooting steps, like verifying the NIC is working properly. You can do this through the device manager. For portable computers with built-in cellular access, you should verify their BIOS settings. Cellular access can be disabled in the CMOS. Or possibly the wireless access point itself needs to have its firmware updated. Next, you should verify that the network settings are correct. Do you have the correct SSID, and are you set to the proper encryption? Then verify overall connectivity. Look at the signal strength and the link state of the wireless device. And then, of course, try to identify any sources of interference, like mirrors and other radio wave emitting devices. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.